Greetings, ladies and gentlemen. Today we're looking at page 600 from our text. We were talking about exponential functions, real roots, real exponents. That's what it was. But some of those were roots, I suppose. So here we're looking at problem 19, and the instructions said to refer to a graph on a previous page. So I'm going to try to pull that up. Hopefully it's not still blurry. Oh, it's blurry, of course. And I'm interested in finding out what is 2 to the negative 0.5 from this graph. So let's see, I think I only need like this section of it. But I believe we might be able to figure this one out without the graph as well. So if I want to figure out what the value is when I plug in negative 0.5 for x, here's negative 0.5 right over here, and the height appears to be about, they said 0.7. I think that looks about right because it's 0.3 away. So 0.7. Now, however, 2 to the negative 0.5, I actually could have done a little bit of work too. I could have moved that downstairs and it would have been 1 over 2 to the 0.5, or 1 over 2 to the half power. And what is a 1/2 power the same as? So yeah, that's the same as 1 over the square root of 2. And then if I wanted, I could actually get rid of the square root. Let's see. Multiply by rad 2 over rad 2. And I'd get root 2 over 2, which is about 0.707, I believe. So in this case, we actually could have found an exact value and stuff like that, but they just wanted you to be able to read it off the graph, so that's what they were looking for. So other questions on the homework?
Yeah, for real.
All right. Oh, don't get the blurries. And good. Actually, I'll re-snap that because it had the little box in front of it. Here we are. Scrolling down. Paste. And that looks about good. So it says, find the values of A if the graph of an exponential function of the form y equals a times 3 to the x passes through the given point. So earlier we said that, alright, so this one's tripling every time, and depending on what a is, it can flip this upside down, or it can stretch it vertically, is what's happening. So if I've got y equals a times 3 to the x, what I can do is, you may recall actually, back in the days of y equals mx plus b, once I found the slope, I'd be able to plug that in for m, and we'd be looking for the y-intercept b, and they'd give you like a point or something like that. And what we would do is we'd plug in x and y, plug in that point for x and y, and we'd plug in m, and we'd solve for b, giving us the y-intercept. That's essentially what we're going to do here. So for like 33, for instance, I would plug in 2 for x and 36 for y, and I'll solve for the part I don't know. Classic algebra setup. So I'll have 36 equals a times 3 squared is 9, and then I would divide both sides by 9, and I'd get a equals 4. So that's a way that you can solve for one of the components of your equation if you know perhaps one of them while solving for the other. So let's look at like 37, for instance. So we'll plug in 27 for y. We're looking for a, and we'll plug in 5 for x. So plug in what we know, solve for what we don't. 3 to the 5th, what's that, 243 is it? I believe. Yeah. And then I would divide both sides by 243. And both of these are divisible by 9. Actually, they're both divisible by 27, apparently. It reduces to 1/9. So that's the idea behind those. Yeah, I don't think we directly did one of those yesterday. So, understandable. Other questions?
29.
29? Yep. I like 29. So here's using some properties of exponents with these crazy new irrational exponents, I should say. And the issue is I can't use any properties of exponents unless these are written in terms of the same base. So it turns out 64 is a power of 2. That's the same as 2 to the 6th. So 2 to the 6th to the square root of 7 divided by 2 to the square root of 7. So I could write that as 2 to the 6 roots of 7, because I can multiply those exponents, divided by 2 to the square root of 7. And then I could subtract the exponents. So I've got 6 roots of 7 minus 1 root of 7. So that's 2 to the 6 roots of 7 minus 1 root of 7. So that's just going to be 2 to the 5 roots of 7. Which, if I wanted, I could actually do the 2 to the 5th portion and get 32 to the square root of 7. The book apparently liked this answer better. But recognize both of those either way. And how about one of these last batch, solving 47? Was that, well, actually that was the questionable scribble up on the board, whether that was 44 or 47.
That was 44.
It said 44 on mine.
It did?
Yeah, it did say 44.
Very
We
well.
can do 47 either way.
But you should do 44.
I might do both. They're both beautiful problems, and neither of them should be neglected. Maybe. I don't know.
Just see what you draw. 47.
I need to get cool sound effects so that when like I increase the size of this, it'll go or like get some cool Mario noise. What's the sound of him eating a mushroom? That's actually weird. Why would he have that much of?
It's like maybe
That was more the tube sound, but it was something like that. Yeah. But either way, it was like an increase in size thing that he did. But yeah, I don't think I make a lot of noises when I eat mushrooms, but I figure mushrooms are kind of soft and like Mario just must be a weird chewer. I don't know. 44. 1/9 to the m equals 81 to the m plus 4th power. So 1/9 and 81 can both be written in terms of the same base. Actually, there's two ways you could do that. You could write those in terms of powers of 3 or in terms of powers of 9. So I'll do powers of 3 just for fun. So 1/9 is the same as 3 to the negative 2nd power. And 81 is the same as 3 to the 4th power, I believe. And then I can multiply these exponents, and I'll be very careful to distribute that 4 to both of those. So this would be 3 to the negative 2m equals 3 to the 4m plus 16, right, because of the distribution. And now I've got two powers that are equal to each other. Their bases are the same, friends. So therefore their exponents must be equal. So negative 2m equals 4m plus 16. I could then solve, I guess, normally I'd, actually, oh, what am I doing? Wrong color. Normally I'd move the 2m over here, but why not? I'm not afraid of negatives. I ain't afraid of no ghosts. Let's see, negative 6m equals 16. And then I could divide both sides by negative 6. And hopefully this is the answer. M is equal to a negative, looks like 2 goes in both of those, 8/3. Is that right? That's right. And then for 47, I'll at least get us to the setup. 25 and 5 can both be written in terms of powers of 5. 25 is the same as 5 squared. Let's see, I'll write that over here. Do I normally put, don't I normally circle the problem? Yeah, that's weird. I just suddenly switched. I usually do this, circle them. Oh well. 5 squared to the x equals 5 to the x. It looks like it's like 1 pixel above. I'm guessing it's squared minus 5. Maybe. Actually, yeah, there's 2 answers, so it must be. Actually, at first I thought that said negative 3.5. But yeah, it's got to be a quadratic in order for that to work.
Is it -15?
That would be helpful as well. So 5 to the 2x equals 5 to the x squared minus 15. I've got 2 powers that are equal. Their bases are the same. So friends with our cell phones, put them away. And we could set those exponents equal to one another. Right, my cell phone friends? Cell phone friends? Yeah, so let's see, we then subtract 2x from both sides. Because it's a quadratic, I want to set this equal to 0. And I'd like to keep my quadratic term positive. So x squared minus 2x minus 15, if I flip things around a little bit, equals 0. And you guys have a plethora of ways of solving this. You could use factoring if possible, completing the square, quadratic formula. You could use Descartes' rule of signs and figure out how many solutions and of what type there are. You could use the rational root theorem, do the p's over q's, synthetically substitute until you find the roots. Yeah, lots of options. But we'll just factor it. So factors of 15 are 1 and 15, 3 and 5. Which of those subtract to be 2? That's the 3 and the 5, if I might say so. And this is a simple factoring problem because there was no AC method. I didn't have to account for the 1. So I'll just have x with a 3, x with a 5. And you guys know where it goes from here. Plus 3 minus 2. And then I'll end up getting x equals negative 3 and x equals plus 5. Because we know that these are the factors, then the roots are the opposites of those numbers. Right, so we can sort of skip that step these days. All right. Well, anyways, so that's a whole bunch all about exponential functions, etc. All right. Well, thank you. Bye, Internet. Bye, Internet. We'll miss you, Internet.